When does a magma stop rising? The magma will rise as long as there's a density difference between the magma and the material that it is rising through. So the magma will rise out of the mantle because the magma is always lighter than the mantle, and it rises into the crust, and it still continues to rise because the magma is initially lighter than the crust that it is rising through. But there's a very strong density gradient within the crust. So as you go higher in the crust gets lighter. And it gets lighter because the pressure is lower, allowing lower, denser rocks to be stable. And the magmas rise until they reach their neutral buoyancy, which is usually the bottom of the first sedimentary layer in the crust. And that's usually within the upper crust. So at a depth of about 10 kilometers. And here's a simple diagram showing how that process works. The magma forms somewhere in the mantle. It's driven out of the mantle by the buoyancy difference between the magma and the crust. It rises up to the mantle crust boundary, but it still continues to rise because the lower crust is very dense, and it's denser than the magma, and the magma continues to rise until it reaches some point in the upper crust where it reaches its neutral buoyancy level. At that point it spreads out to form a magma chamber, and the magma starts to crystallize in that magma chamber. Remember that the buoyancy or the density of the magma in the chamber is the same as the crust that's hosting it. As the magma crystallizes, its water content increases, and water is very light, and so the density of the magma increases, and eventually the density of the magma increases sufficiently that it gets enough buoyancy to break the overlying crust and rise to the surface to form a volcano.